Hi everyone and welcome to Mike Likes Robots. Today we're going to look at how to connect a ROS2 robot to IoT Core. So if you haven't seen my video on IoT Core, I recommend you take a look at that. I'll leave a link at the top. And we're looking at connecting a ROS2 robot. ROS2 is Robot Operating System version 2, and it's not really an operating system, it's a collection of tools, build tools, software modules that help build a robot very quickly and allow you to run your own code as ROS2 modules, or nodes as they're called in ROS2 language. ROS2 also communicates using a publish-subscribe model, same as MQTT with IoT Core. So what we're going to look at today is provisioning an EC2 instance to be our ROS2 robot and forwarding a topic from ROS2 into IoT Core. Let's take a quick look at publish and subscribe. This is the ROS2 documentation, and it's got these diagrams, which I think are really excellent. It shows how you can have different nodes communicating on different topics. You'd have a publisher node publishing a message, which is subscribed to by the subscriber node, and you can have multiple nodes being different publishers and subscribers. So this is great. So we can imagine from this that not only do the nodes on the system get published and subscribe, but if we convert those topics to MQTT, as I'm going to show you today, then we can get those topics in the cloud. Now, why would we want to do that? Well, there is a blog here from AWS. There's sample code as well for pushing ROS2 topics into the cloud. It gives several reasons, but the basic reason is there's so much more you can do with the data if you collect it all together in the cloud. So let's say we want to have a fleet manager in the cloud that tells robots what to do. It tells them to go to the charger if their battery percentage is low. How are we going to handle that? Well, one way would be to push the topic that says my battery percentage is this up to the cloud and let the application there handle it. Maybe we want structured data for machine learning, or we just want to record everything that's going on so we can look at it later and try and figure out if something's going wrong. All of this is possible by pushing robot data to the cloud and then making use of it there. So step one of that, pushing the data to the cloud. And we're going to use this sample repository to do that. So before we start looking at running through the instructions that are available in this repository, we're going to create an EC2 instance to act as our robot. So we're going to open the EC2 console and launch a new instance. And we'll call it ROS2 test. Now ROS2 does work with different operating systems. The recommended one is Ubuntu, so we're going to use that on our EC2 instance. Also makes the installation steps easier. Now, a micro instance is fine for our needs. We don't need anything too beefy. I'll set proceed without a key pair because I like to use the key pair that's already on my system. I just always connect to it through the console and add my own key instead of generating a new one. We'll leave the security group as it is, and we're going to assign a larger hard drive space. That's going to give us a bit more room to download the ROS tools and the source code to be able to use those. So that's everything. Let's launch that instance. And we're immediately going to try to connect to it. Now it only takes, I'd say, 30 seconds to a minute for this instance to be ready. So we're going to try and connect to it, and we'll just keep refreshing until it's ready to go. And we're in. So first thing I'm going to do is update the system. And that's our EC2 instance up to date. Next, I'm going to add my key to the authorized keys. And once the authorized key is present, we're going to switch to VSCode, and I'll show you how to add that as a host that we can connect to in VSCode. So here we are in VSCode. If you haven't installed it, you can install the remote SSH plugin by searching SSH and it will come up, which will give us this new Remote Explorer tab. If we click on that and then right-click the SSH section and open SSH config file, it will give the path to the default config file. I've already got a couple of targets here, and I'm going to take the existing target and add a new one. It'll be called Edge3, and then I'll grab the IP address of the new instance. Once I've added that in and saved the file, we can refresh the targets, and Edge3 comes up. I'll open it in this window. Select Linux, and accept the fingerprint. Then it will download the VSCode server and allow us to operate through SSH. Okay, so I've just opened a new terminal, which will allow us to get the source code from the GitHub repo. So let's have a look at that. So the instructions here guide us through how to set up the AWS CLI before we do anything else, before we clone the repository. So we're going to work through these steps one section at a time until everything is working. So first, let's install the CLI. Paste that command in, but unzip isn't installed, so let's install that. And then we'll repeat the previous steps. And that's our AWS installation complete. We can double check it worked by passing the version command in. And it's returned the version. Now I'm going to use this call to check the caller identity. It's a useful command to check that programmatic access is working, because it just returns the account number and the role that's used to make the call. So if we execute this, it says unable to locate credentials. It's not been configured properly. Now, if we look in the browser, it's expecting environment variables. That's another way to do it, but I'm using credentials so that it persists between sessions and across terminal sessions. So we're going to edit the credentials file directly. We could use AWS configure like it says, but I know the credentials that I want to paste in. I want to use the default profile. So these are the variables that we need to set, or the credentials that we need to set to get access. So if I was to create a user in AWS and attach an API key to it, then I would put the credentials here that it gives me to be able to access the API. So I'll be back in a moment once I've set my own credentials here, and we'll see if it's worked. So that's my credentials set. Let's see if they've worked. And there we have it. We have a user ID, an account number, and a role on that I'm authenticated as. That's everything I need to be able to make API calls using the CLI. So that's our AWS CLI completely set up. We've got access to API calls. But there wasn't only the AWS access keys as part of this command. We also had the region that we need to set. So if we go into VSCode and paste those in, now the default region and the AWS region are set. But what I like to do is save those variables for use in different sessions. There's a file called the bash rc, which is, I'll show you here. This file is run automatically for every terminal session, and it's where you can store environment variables that you want for every terminal session. So if we navigate to the bottom and add these variables in, now any terminal that we open will have these accessible. This won't be the same for every shell, by the way. This is only in bash. If you're in Z shell, for example, then it's a different file called the zushrc. So that's our variable set in bash rc. One extra note is that these won't take effect until you source the file or open a new terminal session. So for example, if we set testvar as 4 and save the file, there's no value there. To access this value, we have to source the file, which we can do like this. Now the new variable that we've set should be accessible. It prints out 4. So there it is. So let's proceed with the instructions. And now we need to install the Python SDK. And we have no module named pip, so we'll do a pip3 install. Which is also not found, but tells us the package manager command to install it. So now we've installed it, we should be able to install our own libraries. We can install the IoT SDK, and now that's installed. And finally, we can clone the source code. Okay, that checked out very quickly. Let's take a look inside. And using the -r flag, we can change our window to open that folder. That means that the File Explorer on the left will show all of the files in that repository, and we can take a look at what's inside them. So we can look at this folder, we can look at others. We can also still have our terminal open, so we can have in one window file list, a terminal, and the source code that we're looking at. So I'm going to keep bash rc open so that we can add to it as we go. Open that at the end. Now the instructions tell us to go into this folder and do a colcon build. So let's follow that. We go into the workspace and execute colcon build, but user bin colcon no such file or directory. So this is an expected error because while this is a fresh EC2 instance, it doesn't have ROS2 set up. So the next step is actually to install ROS2. So let's take a look at the documentation. So we can open the ROS2 documentation and go into the installation for Ubuntu, and then we'll follow these commands instead. Let's blow that up a bit. So we add the repositories to the package manager so it knows how to find ROS2. We install the GPG key, which means it can verify that the packages are coming from the right place. We'll add the right distribution and then update. And with that, we now have access to the ROS2 tools through the repository, through the package manager. So now we can install the desktop, which is a large bundle of tools, or I'm going to go with a more minimal install, which is the base install plus the dev tools. And with that, all of our tools are installed. We now should be able to do the same build command that we did before, and it will work. So the command has finished building, but unfortunately, we seem to have an error. Now this error is actually expected because part of ROS is that it has a bunch of environment variables that it wants you to set up every time you use or run a node or run a build tool. So we can do that quite simply with We source opt_ros humble setup.bash, and then everything is enabled. Let's try again. And that's our build complete. So we're going to switch to this window, which is a preview of the README from VSCode, which gives us the same information as in the browser, but without having to switch back and forth. So after the colcon build, we can copy the source command. So this is in addition to the ROS variables. There's variables for the workspace. So each time you want to run something from a particular workspace, you would source the setup.bash from that workspace. So as the README says, the code is now built, but to be able to run, you'll need to set up certificates. So that's what we're going to do over the next few steps. First, we're going to set a few variables. Now, the instructions say to run these directly in your terminal, but as I said earlier, I want to keep them for future use, so I'm going to put them in here and adjust them here. My thing name will be test ROS2 thing. Everything else is okay. So I'll save that and make sure to source it again. So now all of these variables are available. I can echo this variable and it's got a value. Great. Okay, so next we're creating an IoT thing with corresponding certificates. So first I'll show you what's happening in the console, so something familiar, and then we'll do the command line version. So if we switch to IoT Core in the console, we'll open the Things tab and create a thing. This will be test ROS2 thing console. We can ignore all the extra configuration, no device shadow. We will auto-generate a new certificate, although we'll run everything through the thing generated by the scripts, so we won't use the certificate. This is just to show the equivalence. So we'll auto-generate that. We won't attach any policies. That's done in a separate step later. We create and download. Now our ROS2 thing console is ready. So let's do the same using the command line. So now we're back in the README and we're going to do the same operation on our first thing. So we'll take this entire block of code and execute it all at once because we know what it's doing. It's creating the policy file, editing the parameters inside that policy file, and then pushing it to the cloud and attaching it to our certificate. We get this block of text back, and it shows the policy that we've uploaded has been successful. We can see in the preview as well that it had something similar. So that's our certificate setup complete, all of our permissions set. So let's take a look at the policy and see what it's allowing for us. This is our policy, and we can see it's allowing us to publish, receive, and retain publish messages on this topic, and only this topic, not allowed to publish to any other topic. The same with subscribe, only allowed to subscribe to this particular topic. Now this has a different field, it's a topic filter instead of a topic because you can't publish to topics with wildcards, but you can subscribe to topics with wildcards. So it's a filter rather than a topic specification. We're also allowed to connect, but only if we're using this client ID. If we connect with any other client ID, the connection will be refused. Okay, so that's the policy attached, which completes our certificate setup. Our things are now set up with all of the permissions that they need. So let's test it out. We'll run split terminals so that we can see the outputs of two nodes at the same time. And we're going to copy these code blocks. So the first produces mock telemetry. It's producing a fake battery percentage and a fake velocity. And we can see this with the next command. ROS2 topic echo will print out everything on a particular node, on a particular topic, sorry. And we can see that the battery data is being put out and the velocity is being put out. So with that being put out, now we want to start pushing it up to IoT Core. To do that, we'll just copy this block of code, which sets our parameter that we've already got set, and sources our setup.bash, and then runs the node with our configuration file. And then when we run this, the first step, it shows the configuration it's loading, and from then on it's showing all the data that it's pushing up to the cloud. So now if we take a look at the browser and go to the MQTT test client on the left, we can subscribe to this topic like this, and if we favorite it, it will always listen for it, and we can see that the data is coming through. So that's it. We're pushing data up to the cloud from our ROS2 robot. So overall in this video, we showed a source repository from AWS that contains a sample ROS2 node for pushing ROS2 topics into AWS IoT Core over MQTT. We also set up an EC2 instance to pretend to be a robot and upload fake telemetry data. But here's the challenge for you. Can you take this repo and adapt it to push different topics up to the cloud? Maybe you can publish different fake data on a different topic. There's a few elements to make it work, so let's see how you do. Let me know if you enjoyed this video and what you'd like to see. Thanks for watching, and I'll see you in the next one.